be so much fun. I think it's easier to use than an exchange.
Well, yeah, it makes sense. True.
All right, so I would like to make sure that everyone has seen this Piazza item. So I've posted the solutions for homework 5. And why is that important? What does it have to do with the midterm?
It's going to be on the midterm.
Yes, so I will ask a question about my solution, not your solution, my solution of homework 5, right? So what you need to do is look at my solution before the midterm. You don't have to. If you yes, it's totally optional. But if you want to improve your chances, and what's not to like about that, have a look at that. And so I think the simplest thing to do is to look at to run my test cases and figure out where did my test cases fail on your code, and except for one. In words, one person, at least one test case failed for everyone else. So look at a test case that failed for you, and then see why didn't it fail for me. That should give you something that you're keenly interested in, because it points to something where your solution was wrong. That's wrong. Okay, and so you want to look at why that was and where mine was not, so that and then you can just generally poke around and see what it is that I did. So there will be a question about homework 5. There will also be a question about homework 4. And I can't even remember what that was. Oh, yeah, I know I remember. Okay. So, homework 4 and 5 are pretty similar, right? So since you know homework 4 at this point because you looked at homework 4, since that was the starting point for your homework 5. Homework 3, there'll be a question about, and so again, I think what would be really useful in homework 3 is have a look at the classes that you used in your solution. Have a look at the classes that I used in my solution. And I'm not saying in this case that mine is better. It'll just be different. It'll almost certainly be different from yours. And ask yourself, what is the difference? And then, you could form an opinion and say, clearly what I did is I sliced up into different kinds of superclasses than most of you did, and ask yourself, why did I do it like that, and is that actually a good idea? And I'm not saying it was a good idea. I may have just done that to come up with a different way of doing it, but there's some good idea in there. So have a look at those things. And then that'll be really important for the exam. The other thing in the exam is you will have to draw some diagrams. So it would be a really good idea if you had on your laptop a UML editor of your choice installed, and so that you knew how to do that reasonably quickly. One of them will be a sequence diagram, and when I at one point tried to draw that sequence diagram by hand, I very quickly switched over to just an editor because I made a couple of mistakes, and then that in a sequence diagram they're really tedious to recover from. So put a UML editor up there. When you save your file, make sure to save it as a PNG file, because I may not have the same UML editor as you have, and so the raw output would do me no good. So you're going to be here on Wednesday. You're going to be having your own laptop. You're going to be making a directory called Exam1. In that directory, you're going to be having some files, and you're going to be doing a little bit of programming. So there'll be a project in there. There's no law that says you have to wait until Wednesday to make the subdirectory Exam1. There's no law that says you have to wait until Wednesday to put some project in there that might be called Exam1. Right? Just make sure you don't have a source directory. Just put it right there. Just start off with something, with some trivial file, some hello file. Put it in there, and then you're ready to go. Right? Then you can just start pouring things in there right away. Also, it would be a good idea to have the solutions to homework 3, 4, 5 at a place where you can quickly find them. So if you come in, have all of that prepared, then you're in good shape. Like I said, you're going to be having to run git commit every 10 minutes or so. You don't have to push, you just run commit. And that clearly is meant, 1, to show that you know how to run git commit, and 2, as an anti-cheating exercise, because it would be really hard for you if you were also trying to share with someone else to keep up a convincing git commit record at the same time. Yes?
So in homework 4, you wanted us to put mod count in the classes, but you told us to make it private. Or sorry, homework 5.
Well, so there must have been some confusion, and I actually changed I had a test case that peeked into it, and I took it out.
Because
Because
the test case is still here.
Is it?
Yeah. Assert equals 4 comma set dot mod count. Mod count has private access and erase it. Well,
Okay, send me an email about that. What I meant to do, and I thought I did that this morning, is remove that test case.
okay.
Maybe I zipped it up before I removed it or something.
Yeah, because in the homework 5 you had it.
Okay, so in homework 4, I tested a bunch of private features, right? And in homework 5, I intended to do the same thing, but then about 10 students it wouldn't have compiled at all, and they said, well, that's a hassle for the grader. So I took out, there was one test case, the one test case that in fact I had posted on Piazza, that a bunch of students failed because it didn't compile. And then I took it out. So I'm pretty sure that what I sent the grader does not have that test case, but I would like it so that it's clean. So send me an email, because I will have forgotten by the by the end of the lecture. All right, so that's it. The other thing is, so we're going to be having a lecture today, and one thing of today's lecture will be covered in the exam. So pay close attention to that. Maybe it'll become clearer later what that is. All right, so this lecture we don't have, in the interest of time, any clicker questions. Any questions from you while I'm fussing with this stuff here? Okay, seeing none. So this kind of gets us into the key part of the course that has to do with design. And so I want to motivate things with an example. At this point, we all know more than we ever wanted to know about iterators. So when you have a collection, you ask the collection, give me an iterator. You get an iterator. You can now use this familiar loop. While iterator has next, you keep calling next. And that's how you can inspect all of the elements in that collection. Now, particularly those of you who have taken a data structures course in C++, can I actually just have a show of hands? How many of you had data structures in Java? How many of you had data structures in C++? Okay, not very many. All right. So those few of you who had it in C++ will probably not have seen iterators at all. The way one traditionally taught data structures is like look at the linked list. That you say, no, what's a linked list? We have links, and a link has a data field and a next field. And if you want to traverse the linked list, you just do it like that. You look at the link, and then you say current link equals current link dot next. So you manipulate it with the raw links. Now, of course, if you've ever had a course in data structures where you had to do that, they say, here's a linked list with links like that. Reverse all links. Then at this point, you know that happy times are over, because it's very difficult to get this right. You're almost certain to entangle yourselves with some of the links, which is exactly why data structures instructors love to give these exercises. And so it exposes an implementation detail, and it's also super error prone. So it's not a programming style that we like. And so the iterators were meant to kind of hide the implementation. So we like to think of a data structure as having a high level and a low level view. The high level view is just what do we look at when we see the data structure. So the classic example is the queue. With the queue, we couldn't care less how it's implemented. It has a place in the back where one inserts. It has a place in the front where one removes. That's what the queue kind of intuitively looks like. The same thing with an array or a list with random access. Each position has an integer index, and you can call get and set, and you can get at any of them at the same speed. So that thing kind of breaks down with a linked list. That, we know a linked list is somehow a sequence or something, but you immediately start thinking of the pointers that join the individual links. And it's not so clear how should you manipulate it without knowing about the internal representation. So one model that exists is you could think that a linked list should also have like a cursor, where you can advance the cursor, and then you can advance again. Then you have an operation that says, tell me what's under the cursor. Or with a linked list, remove the element under the cursor. Now, with a linked list, you may never have seen a library where that is the case. but you've almost certainly used something where you have a similar sequential data structure where you do have exactly this programming model, namely files. If you have a random, no, I shouldn't say that. If you have a sequential file, that's how it works. You have a file pointer, and it moves forward, and you can read something under it. So why don't we just do that? It's a simple model. You are given a linked list. You just manipulate that cursor, and you can read off anything that's in the linked list. Just like what you do with the file. You open the file, you keep on reading from the file, you get all of the elements on it. What's not to like with a linked list? They could simply do that. The disadvantage is that if you have a cursor, there's only one piece of your code that can iterate through the linked list at the same time. What you would not be able to do, for example, is, let's say you wanted to decide whether the linked list is a palindrome. You wouldn't be able to have a cursor here and here and move them both, because there would be only one cursor. With the iterator, of course, you can have multiple iterators attached to a linked list, as long as all of them read. As you know from homework 5, if one of them reads and one of them writes, that doesn't work so well either. So an iterator is better than a cursor, because an iterator, you can attach as many of them as you like, as long as all of them read. So what happens here is that over time, people went through different ways of looking at how do you work with linked lists. They started out saying you manipulate the links directly. It's doable, it's efficient, it's just somewhat error prone. They said, maybe the cursor is a good idea. It's easy enough to do. You just have one extra pointer that points to the current element. Doesn't really complicate the implementation. Great disadvantage, though, is that only one cursor per list. What if you need more than one? And then some people came up with these external iterators, which are not natural things. You've now implemented a few of them, and it took, at least I would imagine from some of the Piazza questions I saw, it took some people, some convincing that this was, what does one need to do this? Is this the right thing to do? And so on. But ultimately, the iterators are a superior concept. And so what we would, as programmers, now like to take away from that is that iterators are basically a good idea. Not just for lists and sets, but maybe also for other things. Iterators are better than a cursor. Iterators are better than mucking with the internals of the data structure. And so this something, or rather, is a good idea, is not something that is knowledge that's a little bit difficult to encode. So in 46B, they told you, here's how a linked list works. Here's how a binary search tree works. Here's how a red-black tree works, or whatever it is that they taught you. So they gave you very concrete kinds of things. They said, this is a data structure that someone came up with. This is an algorithm that someone came up with. Here are all the details about this. But it didn't really give you much guidance on the higher level. That if you have something that no one has implemented before, what's a good way of doing something? And that's what the design patterns are trying to give us. So about 20 years ago, some people who had a bunch of this advice that they wanted to impart on others hit upon an analogy in architecture. That in architecture is kind of the same thing, that at the low level one has to teach the students how to make buildings that don't fall apart. But at the next level you want to also say, now, which things are well done. And so there was this guy from the University of Berkeley called Christopher Alexander, who wrote a book called A Language of Patterns, or some such thing, and in which he has hundreds of patterns. And it's actually a kind of nice book, so if you can check it out from the library and have a glance at it. It's most of the things being architecture are fairly common sense. So I'll give you an example of one such pattern. It's called short passages. And so this picture is taken from his book. And so this is, of course, a picture of where he shows something that is bad. This is not how someone should architect a hallway. And then in his article, he goes on for a long time, for a page or so, talking about long, sterile corridors set the scene for everything bad about modern architecture, and so on, and so on, and so on. There's a page or so where he describes what's bad about it and why it's bad. So he says, it's depressing. There's no light. There's no place to put any furniture. He quotes some research on anxious patients who somehow get out of their room, get into one of these corridors, and then they get really nervous, or whatever. And so, in fact, that research suggests that if the length of the corridor is more than 50 feet, then patients get all antsy about it. If it's less than 50 feet, they're okay. So that was what someone chose to write a research paper about. So he goes and describes all of this problem from what he knows from his experience, so that now that we all know that this is the kind of thing that one should avoid. So if I were to do the same kind of thing about iterators, I would have written about how this kind of stuff is error-prone. I would have given a few examples. Maybe some student code that looks horrific that shows how people mangle up the direct links if you let them at it. Or I would have shown in an algorithm where having a single cursor is just not sufficient, and you would have to copy out the data or something. And that would be setting up the problem. And after that, then he gives a solution. So here is his particular solution. This is Alexander's solution to say, here's how you can make better corridors. And so one thing he says is you should put the corridors along where you have windows, not in the interior of a building. And you should have, so that it doesn't look like one long tunnel, you should have these little breakout things where you put in a bit of furniture so it actually kind of looks like a room. Seems like a reasonable solution that could be applied in a great many places. I don't know about this corridor, but one could if one, at some cost, right? You have to carve out the extra space for this, you have to buy the furniture and so on. But it's a solution, and it's something that an architect can keep in mind. And next time that they see a building plan with a tunnel-like corridor, they could see, well, gosh, can we move it outside? Can we do something? And if you look at the building that we're in, for example, you can see that architects struggled with similar problems, because this building has an H shape. You can see it has these several wings sticking out, and that is to let in more light. You look at other buildings on campus, such as Clark Hall, which is this concrete monolith with almost no light because they just built it as this huge block. And so clearly that was not very good architecture, because you do want as much light in there as possible. All right. So in an iterator pattern, one would put it out like this. This pattern was taken from a different book, a very nice book on design patterns that was written about 20 years ago, where a bunch of computer scientists put together 20 or so common patterns that they have encountered, and that they codified in this pattern language. So each of the pattern has a context that describes the situation in which the pattern would apply, and then it has a blueprint for a solution. So with the iterator pattern, the context mentions 4 things. It says you need to have, for this thing to grip, for it to make any sense, you need to have some kind of an aggregate object that contains element objects. So if you think of a list or a set, that's an aggregate object. It contains element objects, the individual items of the list or set. It must be so that clients need to have access to the individual element objects. In some situations, maybe clients never care about the individual components. For example, think of an integer. You don't normally want to know the bits that make up an integer. In that case, this one wouldn't apply. But for a list or a set, you normally greatly care about what's inside. The aggregate object should not expose its internal structure. So that means we don't want to know how things are linked together. And finally, multiple clients may want independent access. That's what would preclude a cursor from working, because if one client moves the cursor, then the other one can't also move it at the same time. So if you have these 4 requirements, then the iterator can be a solution. Here's the recipe for the solution. Define an iterator that fetches one element at a time. You have just defined such a thing for the bit set, for the array set, so you know very well what that means. Each iterator keeps track of the position of the next element. That's what you've done in homework 5, right? You've kept track of where do I read the next integer in the array set? Where do I need to look at the next bit in the bit set? And if there are several variations of the aggregate and iterator, then it is best if aggregate and iterator classes realize common interface types. Let me show you a picture to explain that. Here it is. So the idea is that we may have different kinds of collections or of aggregates. We might have, like in our case, we have the array set and the bit set, for example. or in the case of the Java collection hierarchy, we have lists and sets and all of that. And then, of course, there are different kind of iterators. And the world doesn't need to know, for using these things, what exactly the concrete iterator types are. It's good enough to know an abstract iterator type or an interface that has some standard methods. And that's exactly what you have done, or at least that you should have done, because this morning I realized that a bunch of code that some of you provided didn't compile because not everyone's iterator actually implemented iterator. Or was it in sequence? Not everyone's in sequence. Whatever. There was some way where it didn't work, and I had to change something to make the code. So, and anyway, so the wisdom that they impart here is try to make both the aggregate and the iterator interfaces so that the clients only need to use the interfaces and don't need to worry about special types such as a reset iterator or such things. They should just be able to work with them as iterator. The other thing that the pattern gives is sample names for the various methods. So the pattern says, you could call this method create iterator, and that creates an iterator. You could give the iterator methods next, is done, and current item. So these are the names that come straight out of the patterns book that they recommend as maybe good ideas to do that. Now, having done that, let's have a look at whether the iterators that we know match the iterator pattern. So if we're just looking here at the java.util implementation. So in aggregate, the abstract aggregate in Java would be a list. A list in Java is it an interface? It's an interface, right? Not an abstract class. It's an interface that says what all lists should have in common. A concrete aggregate would be linked list or array list. An iterator, well, in Java, depending on which level you go in Java, there's two kinds of iterators. They have the plain iterator, and they have list iterators that can go bidirectionally. So either way could be put in here. The concrete iterator, in Java, this is actually correctly done. We have no idea. If you ask a linked list, what's your iterator? I don't know. Yeah, try that. So now I'm getting an iterator by calling a list iterator on this thing. So you may be amused to know that this is the name of the class, Java util linked list $list iter. So it's an inner class list iter inside Java util linked list. You never knew, and neither do you have to, because it's something that's anonymous, that's hidden from you. Now, the create iterator method here, as it was called in the pattern, is now called list iterator, or just plain iterator if you don't care about the backwards. And that's the method that I call. The next method, the one that gives you the next element, is also called next. The isDone method, that's the fictitious method that the pattern people say has a good idea on how you could call it. There is no isDone method on list iterators. If you want to know whether it's done, then you have to call hasNext, which gives you the opposite. But it's functionally the same thing. We're not at the level of where we care about the exact method names. We care about the concept. The concept of isDone and the concept of hasNext, are the same thing. Either way, you can find out whether or not you're done. The one that's a little bit weird is the current item method. So that the way that the pattern people envisioned this was that when you have an iterator, you can call it next, 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 and move it through the structure. Or you can say, what's under you? And you would say, what's under you? Next, what's under you? Next, what's under you? And so on. In Java, that's not quite so. The way they've done it is, oops, and there's a typo here, that that, that you have to call next and catch the return value. So this here should be the return value of next, not of as next. Should fix that. So you can get at the current item, but in a slightly more roundabout way. You have to combine it with the call to advancing the iterator. Not as good, actually, because sometimes it happens that in one branch of the code you want to see where am I currently, and another branch you don't quite remember and you want to do it again, or you don't want to advance. But in Java you don't have a choice. Why did they do it in Java in this kind of stupid way that you have to first call next to even get the value? Does anyone know? I mean, Java does have like the worst iteration protocol that you can that any major programming language has in its collection library. So the reason for that is that the person who implemented this was very enamored with the following loop. That should be an iter. Change this to iter. So he wanted to be able to erase things out of the iterated over structure that fulfill some property by saying, while there's more elements in there, if iter.next has some property, then we want to call remove. And that gives you why remove has to remove the thing that was just iterated over. Now, I don't think this is actually a great idea because how often do you use this kind of loop? Yeah.
Isn't this useful when you do the stream filter thing?
Well, in that case, it's actually the stream filter thing could do it any old way because it hides from you completely how this is done. Yeah. And so even in a modern functional way, nowadays, no one in their right mind would write this loop because you would simply call remove if on the collection.
Yeah.
You would give it a lambda.
Yeah.
And so this seemed like a good idea some time ago, and now it probably isn't. So the fact that the iterator pattern teaches you one way and the implementation in Java is slightly different, in this case points to that the implementer of this, whose name you can look up in the class, was kind of blindsided in this particular way. That's just the way it is, and that's what patterns are all about. Patterns give some good advice that you ignore at your own peril, or in this case, at the peril of millions of Java programmers. So I'll give you another idea of a more architectural design pattern, and then we'll go into a smaller scale pattern from that. So there's this thing called model view controller. And so the idea is that suppose you have some kind of a program that gives you multiple editable views on some data structure. And a classical example from 20 years ago when people did this was an HTML editor. So at the time, HTML was still young, and people said, there's going to be, surely, you'd be crazy to edit the actual ASCII codes of HTML. That's too error-prone. So what you want to do is you might want to have a WYSIWYG editor, like Word, kind of a Word-like HTML editor, and these things still exist. Or you might want to edit the structure. What's wrong with the visual, like with this kind of thing, where you can just see everything? So you have one of those in Piazza, right? You have a little dialog where you can put in like bold and italic and code and code blocks and that kind of stuff. Did you ever run into a situation where that one didn't work for you? You might not, because for a simple comment it's fine. I run into this all the time when I have a situation like you have a slide with code. If you carefully look at this thing here where I have something in monospace, and here I have some comment that's in Roman letters, here's something that's in sans serif font, And so if you mix the fonts more often, then this kind of view becomes just not very workable. The WYSIWYG view turns into what you see. WYSIWYG means what you see is what you get. But once the structure gets complex, it's a what you see is all you've got. And at that point, it becomes important to be able to see the structure. So at the time, they said, oh, we'll give you this kind of structured view that shows you the tree structure. And professional HTML designers still use such products. And so what's important is that you can edit here, or you can edit here. And either way, if you edit here, then this stuff gets updated. And if you get edit here, then that stuff gets updated. And the typical HTML editor will have a third view with a raw HTML text. So you can see that you really get what you wanted to. You might not want to edit it, but you do want to see it. So you have these three different views that all view the same kind of stuff. Now that's not easy to do, because how's it going to work? So you process code that changes the thing here. Then you also have to update the other view and the third view. That gets fiendishly complex. So they came up with a different way of doing that that's much nicer. So whenever you have an architecture where you have multiple visual representations of the same abstract data, then this pattern tells you you should structure it so that you separate everything into three parts, called the model, the view, and the controller. The model is easiest to understand. The model has no visual appearance at all. It's just, in this case, the tree structure of the HTML. The views are the different visual representations that can be very different. This one and that one. And the controller is the user interface part that deals with getting keystrokes and cursors and keyboard shortcuts and all of that stuff. And the basic loop now is the following, that when something is done through a controller that says erase a letter here, insert a letter there, add a new paragraph, something like that, that the controller tells the model and say, hey, your internal structure is now changed. There's now a new letter in this paragraph. This paragraph has been split in two, or whatever. And then the tree structure, which has no view at all, the tree structure just gets changed. A letter gets inserted in the right string. A node gets split into two nodes, whatever. Now the tree structure is different. And then the tree structure tells all of its views, hey, I've changed. Hey, I've changed. Hey, I've changed. And each of the views says, well, that's mighty interesting. He has changed. And then he says, now I want to redraw you. And so the first view says, let me redraw this data structure. The second view says, let me redraw this data structure. And the third view says, let me redraw this data structure. Each of them redraws it in a different way. One of them as a, what you see is what you get view. One of them as a structural. One of them as a plain ASCII view of all the characters. So, the controller tells the model to insert some text. The model tells the view and says, hey, I've changed. That causes the view to say, well, it looks like I need to repaint myself. And in the repaint procedure, then the view says, well, I need to know information about the model, and it calls get text to the model. Notice that the view knows nothing about the controller. The view has no idea that there is such a thing as a user interface. And that user interface can evolve completely independently, and someone can put in menus and shortcuts and touch events and whatever. The view has nothing to do with it. The model has nothing to do with it. The model has no idea how many different ways it's viewed. It is willing to expose information about itself. And the view can then take that to draw itself in any way. So I should say that the model here is, why is it called the model? It has nothing to do with like a model train or a model airplane or something like that. The way you should think of the model is that in an artist's studio, there's a model sitting in the middle. Some artists view this model and paint like a classical realistic picture. Some artists view this model and paint like a modern cubist picture. Some artists view the model and just randomly throw paint on the canvas. And so each of them views the model in a different way. So now I just want to take a small part of this very complex architectural pattern, namely what happens at this level. This part is the design pattern. So in general, we talk about architectural patterns as patterns that model complex scenarios, and design patterns as ones that model more tactical and simple scenarios. So the simple one that I wanted to start off with is called the observer pattern. So the observer pattern always involves that there's a change somewhere in a data structure, and when that change happens, someone who is interested in the change needs to get notified. So in MVC, the model wants to notify the views when something interesting happens. In an entirely different situation, in a Swing user interface, the button notifies action listeners when something interesting happens. The one interesting thing that happens in the life of a button is that someone clicks it. And so, but it's the same kind of thing that you have things that want to attach themselves to something else so that they can be notified. The views in MVC attach themselves to the model. The action listeners attach themselves to the button. The observer pattern talks about one thing, namely how to manage a situation where a bunch of observers attach themselves to a subject. Yes?
So is a button part of the controller or part of the view?
The way that the way that I want to look at it now is that has nothing to do with MVC. You could say that a button also has something to do with MVC, but right now what I want to say is this is MVC. This is an unrelated scenario.
Okay. But I'm just curious, like on an HTML page, when you have a button, the view has to draw the button, right? And the controller is responsible for how.
Yeah, I don't want to get into it
Okay.
because it would completely defocus this example. Let me try to think if I can, off the cuff, think of something else where you want to have. No, I'm not going to wing this. So think of this as knowing nothing about visual anything.
Okay.
The buttons are just there in the user interface. Nothing to do with. And so, what I want to say is, you have a situation here where you have one model, which has it's a data structure, and there is a need for other things that happen to be the views to be notified when the model is changed. In the situation with the buttons, you have one thing, namely the button, and there's a need for other entities, namely the action listeners, to be called when something changes in the button. That's all I want to say. And so we're going to model this very mundane kind of thing. You have a subject, that's the thing that once in a while will change in a way, and you have these observers that want to be notified. So all we're going to be talking about is how can the observers attach themselves to the subject and be notified. That's what the observer pattern teaches us. It doesn't teach us about MVC in general or anything. It just teaches us about this little thing. Doesn't sound like a big thing, but here's what the observer pattern teaches us. It says that when you have an object that is a source of some events, and you have one or more observers that want to be notified. Here's what you should do. Number one is you should make an observer interface type. We should make it so that all the concrete observers implement that. We should make it so that the subject maintains a collection of observers, say an array list or linked list or something. We should make it so that the subject supplies methods of attaching and detaching observers, where an observer can say, I want to now start listening, or I no longer want to be listening. And finally, when an event occurs, then the subject notifies all of the observers. So here is a sequence diagram for that. No, sorry, yes, but it was the class diagram. So the class diagram says that we have the subject, that's either the model or the button or whatever, and we have an attach method that allows, and a detach method that's not shown, and that allows observers to add themselves to it. And then there's this observer interface. That's all that the subject knows about it. To be an actual observer, you want to implement that interface, and you want to override the notify method. No, I didn't. For some reason, I don't have a. Hey, that would have been a great exam question. Okay, there's no sequence diagram. So here's an example on how that plays itself out in the case of the action listener. So the subject is the J button. The observer interface is action listener. The concrete observer is the class that implements the action listener interface type. That's often a class that you don't even see, because when you write out the action listener as a lambda, the class gets generated automatically and you have no idea what it is. The attach method is called add action listener, and the notify method is called action performed. There actually is a notify method that has nothing to do with this. So that shows how the pattern is used in this particular context. And it's used in many other contexts. It's very, very common that you have something that needs to, where you want to find out if something changed. In fact, just over the weekend I had to do this thing where for some interactive parts in an ebook that had to be reported out to a learning management system, I had to attach listeners to each of the interactive elements, and every time one of the score changed, it fired a method. So it's a super common way of listening to something, and it's called the observer pattern. All right, that's how far I wanted to get with the patterns in the lecture. Let me verify that actually. Was that how far the reading went? 5.1 to 5.3? Okay. So in the reading, we didn't do layouts, right? Did anyone do the reading? Okay, thanks. So now in this short lab, I want you to do the following. So I'm giving you a file called Slider Demo that does something with sliders. And sliders are kind of like buttons, except they, as you'll see, they slide back and forth. And as they slide, one wants to know, how did they change? Where are they right now? And so this way you don't use an action listener, but a change listener. And you can find out how to do that. And you can just look at the program. And now what I want you to do is the following. There's this table that we had here. And I want you to draw up the same table, except in the case of sliders. So that should take you a few minutes to see the lay of the land, to see how the sliders operate. And I think then it'll be fairly straightforward to just do it by imitation. And then the more important part here is the following. Oftentimes when students see these patterns, they make the mistake of looking only at the name of the pattern and not at the more important parts, namely the individual pieces. So when you look at the observer pattern, for something to be an observer, 6 things have to be fulfilled. Number 1, there needs to be a context where an object is a source of events. Number 2, there needs to be these observers. Number 3, there needs to be an interface type. Number 4, the subject needs to maintain a collection of these. Number 5, the subject must do this, and number 6. So all of these points here must be true, otherwise the pattern is not actually in use. And it's a dangerous thing. There's a pattern called the strategy pattern. And in every course, in one of the exams, I put on a question that says, does this thing, is this an example of the strategy pattern? And every time, no matter how often I warn against it, about half of the class says, well, that looks pretty strategic. So it must be an example of the strategy pattern. And that makes no sense, because the strategy pattern has like 6 items. And all 6 of them need to be fulfilled for it to actually apply to the situation. Whether this is strategic or not has nothing to do with it. And so I want you to practice this kind of critiquing of a pattern here. So someone tells you that an iterator is actually an observer. And so tell me why or why not that might be true. Someone tells you that a slider is actually an iterator. Now in this case I'm giving you the answer and say that can't be true. So maybe one of the answers that could be argued. And then if you have extra time, which I don't know, then you can do part 3, where even though a slider isn't actually an iterator, it's not hard to adapt a slider to an iterator. And that also shows up the difference. So get going, get as far as you can, and in the last 10 minutes or so I will talk about these things, because one of the exam questions will be, is this situation a... Okay, how many design patterns have we seen so far? two, right? Iterator and observer. So all I can say is this thing in iterator or an observer. And I don't remember whether the answer is yes or no. But it's one of the two. Okay, so get going with that with your partner, and then 10 minutes before the end of the class, we will all go through it together. No. Oh, of course. Yeah. Never mind the icon labels not showing up. There was supposed to be missing images here. But what you can see here is when I move a slider, you see that the field down here changes. So figure out how that happens.
You finished?
So it's not number one, it's not passive file because the iterator class can actually
Yeah,
Or it doesn't even aggregate. Just go
Okay, it doesn't have an object as a subject and a source.
Yeah, so it has, but it doesn't have a limited alter.
So I guess like
And there's no and there's also no there is no observer interface.
I mean, it's great. It seems like
the subject doesn't maintain a collection of objects.
it still gives some points.
The list doesn't know if it's iterated.
Yeah.
It doesn't tell the iterator what it is.
Right. It doesn't, and the list doesn't aggregate because there are no iterators. Someone tells you that sliders actually through a sequence of that. That's what I always Oh, there's two slides right there. So context is an aggregate object contains element objects. Is that that's it?
Yeah, that's still good.
It does it, right?
I guess we got. I don't even know. I haven't looked.
I mean, sliders don't have like elements. They have like a property. I don't think it counts because it has to look. It has to contain element objects. Sliders don't. I think it's kind of subjective, but I'm pretty sure it doesn't have like a big collection that has elements. It just has like properties. It hasn't its property. So we want because it still wouldn't be an iterator regardless. It says plural here, right? It doesn't expose internal structures. Multiple clients may want to access. Yeah, that works if you consider a property.
I would say because you move it here and then it notifies. When it moves a certain distance, it notifies I moved 75 object.
Yeah, it just notifies you move, and then the thing grabs it. Each iterator object keeps track of the position. There is no next. So I feel like none of this applies because there's no element.
I guess that's a good way to describe
He was talking about like some code check rate or like learning something learned, right? Isn't that what we use for like mastering physics?
the learning
When you
thing.
take physics, like
I
there's
took
like
one of those math
there's like but like it has like I don't know.
I
wonder
like put an answer here.
yeah. So there's it works. Now what if it didn't?
Oh,
Because like I could have sworn like didn't even said something like
oh, really?
it's not familiar to what I yeah. Because there's like a web assign that supports
So you didn't see that because the lambda expression completely hides that part. It just takes a single method, whatever it is, and implement it. So the code, you don't see.
When the slider value changes, the slider value is inserted. So basically, so you start with an empty queue, and then every time you change it, like it's out of the queue. Oh, and then
when
you
you
want to
notify
iterate,
it,
so look for the history.
yeah,
Okay, that makes sense.
notify until
Yeah,
the queue is empty.
this could
again.
actually be useful because you could make like a rewind history thing, right?
If you kept the queue, yeah.
Yeah, and then you can go back and then you can look undo your changes. Yeah, that makes sense. Dude, I'm terrified over this movie.
Really?
Also, I just found out like none of his test cases actually compiled because I didn't read the things to the interface. I didn't read that. What? Apparently, you're supposed to add iterator to the interface. I didn't do that.
Oh, you didn't.
I
It doesn't
just put
say
it.
implemented.
It does say. I didn't guess I just did like I want.
Oh, like this
I remember.
internal class.
Yeah, I remember.
The eraser iterator doesn't implement.
No. Like, good at inset or whatever it's called. Yeah, inset. Inset.
Yeah.
If you control click.
Which he is already using.
Yeah, you're supposed to implement it there. I'm guessing you're supposed to do that, but I forgot.
Oh, you didn't put the.
Yeah, so none of this
yeah,
is compiled.
That would make sense because he calls it as
But then I changed them and it all works.
I didn't pass the test with the infinite. That's the only test I didn't pass. Like this in sequence just goes to 1 and 0 constantly.
Wait, really?
Yeah, see this in
I
sequence.
passed that one, but I didn't like look at it. So
Yeah, because mine didn't pass. And then
it would. That actually works.
yeah, I don't know how he works.
Here's how I implemented it on the TLC. Yeah, maybe if you change it now, it's not too late.
Let's see.
Changes to it. I changed it now. Alright, let me know if you need help with. I probably shouldn't have used like 3 ternary operators.
You just change them together.
Yeah, let me know if you want me to explain it. I was thinking like I should probably make if statements and make them more clear, but then I was too late.
That's what like.
So this, which one?
Was the in sequence has the next as
So this next is not equal to null. That means that either this didn't happen, or this dot next is out of stuff, right? Because if it calls this dot next, it's supposed to return null because it's out of stuff, right? So either it's out of stuff, or we're supposed to return other dot next, right? So then I go into ternary, so I return the dot next that it's supposed to. It's not null. Otherwise, I look at other next and I see is that. Because if it's not null, I want to return it. But if it is null, then I want to return this dot next. This could happen if other dot next is out of stuff. Then, but it's still other dot next is returned.
Yeah.
So then, if it's other next returned and other next is out, then that means we have to do this dot next.
anyways.
Yeah. So it should return null.
Yeah, I'm trying to like see where your
Yeah, I
yours
should've used
breaks.
this statement.
Yeah, I just want to see like where it breaks the because it looks like it
Oh,
keeps getting things.
Because when you do
Test case. Alternate. It's like this, it'll just keep giving you 0 regardless. Whenever you call next, it just says 0.
Yeah, because right here, this will always give you 1, and this will always give you 0.
Yeah.
So what's going to happen is this is going to be 1, and then so it's going to say this dot next is 1. It's not null. It's going to return this dot next, and then other next will always return 0. So this dot next will be null when this is false, because then it will be other next, right? So it goes into this ternary operator. This is null. Or sorry, this is null. So it's not going to go here. It's going to go here, and other next is going to be it's going to be 0. So it's not going to be null.
So I just created an array list and populated first and second. So I get first and I get so this is from the other one. So now I have the first one and the other first one just to run. And then if it's equal to null, the first one added. Or if it's not.
I thought you said you used lambda.
I did lambda for the from iterator.
I thought you said lambda.
I don't know. Maybe that's why you wouldn't need it.
I think you could.
So then it just, if this one's not null or this one's not null, keep running over it and add it to the list and then start with the from iterator.
Well, what if you're out? What if they're both out?
Well, then you would end and you would return list. You have this whole list populated with the new. You return this new from iterator list out here.
Interesting. Oh.
So it just creates a list and generates it in sequence from that.
That's pretty cool.
I don't know, I just was like, oh, just use an array list like that. But yeah, I guess you have to somehow avoid.
All right, let's get going with this. So in this pattern table here, what is the actual name of the subject?
JSlider.
JSlider, that's correct. Okay, the JSlider is the one that people are watching to see how it changes. What is the actual name for the observer interface? Change listener. Why is it not action listener?
Because they don't have.
Well, that's just a JSlider says it emits change events. It doesn't emit action events. And one of the reasons that it doesn't emit action events is the change event actually has the value of the of what is being changed, whereas the action event just says action, action, action. It doesn't have any values attached to it. So this is a change.
Why didn't the developers of Java do it that way? Why did they just say let's follow the standard here, do an action listener, have a get value?
Well, they could have made it so that there is a more generic, something interesting has happened, event listener, say, right?
Yeah.
And they could have had a more generic event. That's what they did. So each of these listeners has its own specific listener interface with its own specific data. And, you might say that is taking the design pattern to further than maybe it should be taken. What is the concrete observer? Some class that implements change listener. Okay, we don't know what class that is, and in fact, in our example, we're really unenlightened. This thing listener here is a change listener. It's an instance variable defined up here. Right, so listener is a change listener, and it's defined as a lambda. So you can see here it's defined as a lambda. That is this extreme shorthand that says listener should be an object of a class that implements change listener, where the one and only method of change listener is defined like this. So there is some class that has a name that we don't know, and That is the concrete observer in this case. What is attach? Does it create change listener? Let's find out where it is. So this listener here, because someone else asked this question, I just looked it up. All the way down here in the sample method, it says for each of the slider we call add change listener. So it is add change listener. Okay, so there is a very definite answer here, and that's generally the change. Well, that's not always the change. In this case, it's add change listener. So, what is notify? So if we look at the design pattern, notify is the method of the observer class that you override. Now, unfortunately, in our code here that you've seen, you don't get to see which method you're overriding because it's using a lambda. And the lambda says, whatever that one single abstract method is that I'm implementing, but you don't get to see the name of that single abstract method in the code. How do I find it? I really have to look at the Java doc, so look at change listener. Oh, it's a super good idea if you have an offline version of Java doc, right? So I have one that I just unzipped on my own computer because you're going to be offline during the exam. So, and change listener has a single method called state changed. So in the olden days, one had to know that because you actually implemented the class with your bare hands. Nowadays, through the miracle of lambdas, it's the compiler that looks up what is the name of that one single method, and you don't even have to bother. But that is what it is here. So it's state changed. All right, that's that. So that's the kind of thing that I'll be asking you to do on Wednesday. And where did the lab go on? Here. So someone tells you that an iterator is actually an observer. Well, I guess an iterator does kind of observe a data structure, right? You get like these observations, and you can attach multiple iterators to a data structure, just like you can attach multiple observers to a subject. So, how many of you think that an iterator is an observer? Nobody thinks. Okay, so people act that kind of thing. So a few people kind of think that. So let's see what it is. I can't remember whether I think that or not. I mean, my intuitive reaction is, well, it probably isn't, right? Because why would they otherwise have two distinct patterns? But I kind of convinced myself at one point that it might. So, so I guess you could view a list or a set as a source of, what's an event. So it's a source of a number. So maybe each number is an event. Okay. So we wanted to notify, well, when such an event occurs. That's iffier, right? We want to know what the numbers are. So that seems tenuous. So we have an observer, iterator, interface type, all of them. Implement that, fine. The subject maintains a collection of observers. Does or does not a data structure maintain a collection of iterators? So think of your homework assignment. In your homework, the subject would then be the bit set or the array set. You have implemented these. Does your array set, does your bit set maintain a collection of iterators? And I bet you it does not. It would actually be a good idea if it did, because then you wouldn't have to deal with a stupid concurrent modification exception. Then you could make it so that if the data structure is updated through one iterator, or through that you could adjust all the other iterators to still point to some reasonable position. That can be done, but it's expensive. And so that's why the iterator pattern doesn't recommend it. You could really make it so that let's say that an iterator, one of many iterators, points to an element that's now being erased. You could move it. Yeah?
If the data structure was the subject, then it wouldn't have a source. It wouldn't be the source of events.
Well, that's a semantic question, right? Then now you have to argue what's an event. And so, I said, what if you think an event is like a number or something, or a sequence of numbers, or a change in the numbers, or whatever. So I said, even if let's say, let's see where this gets us if we take this nebulous point of view. So the hope is that if your task is to prove that something is not an instance of this pattern, that you get to a point that is so clear cut that you don't have to argue all this semantic stuff. And so we've hit it here. Right? It is simply not the fact that a collection maintains a collection of iterators, that a bit set maintains a collection of iterators. One could imagine a different kind of iterator pattern where this was mandated, but it is not. So in this case, we know for absolutely sure that the answer to this lab question is, where the heck is it? Is no. Okay, there's not a question of a doubt. So let's do it the other way around. Is a slider actually an iterator through a sequence of values? And so let's go to the iterator pattern. 2 more minutes. So I guess it doesn't. So now, what is supposed to be what? The slider is supposed to be the iterator, or the change listener is the iterator? This seems very nebulous. So the slider is an iterator through a sequence of values. Does each slider keep track of a position? This doesn't make any sense. There's no common interface type, so I don't even begin to see where this would grip. But so let us quickly go over this thing with the slider iterator and see what this thing does. The slider iterator does something actually that's kind of interesting. So I think this was a poorly asked question. What I probably meant to say is a change listener in iterator, because you attach change listeners to the slider. Never mind what I meant. What I did here, and that is kind of interesting here, is I said, well, what if I do want to iterate over the values of the slider and get them one by one? I can kind of rig to do that, and the way I would do it is I would say, okay, I want to get notified of the events, and then I put them into a queue. And then I could pull them out of the queue one at a time. And that way one could actually iterate over the values. But that's something completely different. That doesn't mean that the pattern applies. All right, so that's what I have. On Wednesday, show up here in a few minutes before. Make sure that your laptop is all set up, and good luck. You'll need it.
Will you be here?